Hello everyone, my name is Pega. I'm from Budapest University of Technology. I'm a PhD candidate actually in both the application of data science techniques in soccer mostly. And I mostly work with the tracking data. Feel free to just interrupt me if you have any question, or after presentation I would be happy to discuss about your comments if you see any problem or any comments in any part that you have. So what I'm going to actually present now is first the definition of the penetrative passes and our contribution to this line. Previous of this project, they are calling it like line breaking passes. I'm going to show how we contributed and what are the differences. Then I'm going to show how did we just use the deep learning actually, or graph neural network, to predict and evaluate these kind of passes in a very interpretable way. And then I'm going to show the risk and reward of the penetrative passes, and finally I'm going to show some use cases. So previously in the too many papers, and not too many, I would say, like there are at least 10 papers that are written about the line breaking passes and some projects by different companies. So the line breaking passes are widely discussed among the coaches and players because they are some kind of passes that are breaking through the defensive line actually. The line can be, for example, a line between two pair of the opponent's players. And because they are usually helping for transiting one team from one attacking transition to another attacking transition, and it may soon result in a goal, it's very important to evaluate the teams and players based on those. And finally, we can use it for the player evaluation actually, and the existing metrics actually sometimes call it like packing passes or progressive passes, and you can find these kind of things as a serving proxy. So how we are going to formulate actually this kind of penetrative passes? First of all, we need to somehow create some defensive zones. In this project, we don't consider that there is a line of the defender. Instead, we are trying to create some defensive zone. If you see this kind of dashed line, and we call it like convex hull. How this convex hull is created is from the location of the opponent's player exactly, who are within the next 85% of the distance between the ball holder and the goal line. So in this case, we can show that the ball should at least go forward like 50% of this distance. After creating this convex hull, which is only one convex hull, can be very automatically created by Python libraries, then we are going to mark all the tracking data as a potential penetrative pass situation. So the potential penetrative pass situation is a situation that there is at least one teammate. You can see the blue player inside the convex hull, who are inside the convex hull. So if there is at least one teammates player inside convex hull and we have a convex hull, we mark this situation as a penetrative pass situation, and we are going to analyze this kind of things and filter the data only for this kind of situations. In order to do that, first I'm going to show how the actually graph neural networks works, but I'm not going to into details, no worries. If you can see here, we are defining 4 kind of nodes. The first type of nodes are the blue circles, which are like attacking team players. The second type of the nodes are the red nodes, which are the defending team players. The third are the opponent's goal, which is this green circle. And the own goal is the left side, which is the yellow circle. And the attack direction is always from left to right. If you can see here, there is a ball holder A, which is the blue player, and we could create a convex hull from all the opponents in the next 50% of the distance. And player C is inside the convex hull, which is teammate, so we can mark this situation as a potential penetrative pass situation. So now we are going to use neural network to understand who is the intended receiver actually, and to predict what player A is gonna do based on the whole data set that we got from the whole league. I'm not gonna tell the name of the league, but yeah, it's anonymized. So if the player A will send a ball to another teammate who are not inside the convex hull, something like player B, we call this as a non-penetrative pass attempts. So if the neural network will understand that there is the most likely receiving player is out of the convex hull, this is the non-penetrative pass attempt. On the other side, if there is the most likely receiving player is player C inside the convex hull, we mark this as a actually penetrative pass attempt because it breaks through the defensive zone, which is this convex hull you can see there. The third situation is if the most likely receiving player is the red dots, red circles, which are the opponent's players. This situation is turnover. It can be interception, it can be tackle or anything. We are not going to details. We are just saying that the ball is lost and the possession is lost. Actually, we call it like turnover situation. Then we have a goal scoring, which is if there is an interaction between player A and the goal line, which is the D. And we are going to mark it as a goal conceding if there is interaction between node A or player A with node E, which is that opponent's goal. So this is a goal conceding, which is usually coming from the turnovers. I'm not going into detail of this, but very quickly, so now we have 4 kind of the nodes, if you can see on the left side. There are attacking players, defending players, and 2 goal lines. And the edges that we are going to predict are the passes and the shots, actually, which are the goals. And the feature that you can see here, all location and velocity and the distance between 2 players and the direction, a lot of things are considered to have as the most accurate intended receiver as we can from the previous data. And the way that is working, it's not very complicated, actually. The left side, you can see the input position, which are some interaction, time-step interaction between players. Now you can see node A1, for example, which is like player 1. In time-step T1 is sending the ball to the player 2, then player 2 to 3, 3 to 4, 4 to 5, 5 again to 2, 2 to 4. And now in the question mark, we want to know what is happening for the ball when player 4 is the ball holder. And we want to know who is the intended receiver. After understanding intended receiver, we will going to say if it is a penetrative pass or non-penetrative attempt or turnover, or goal scoring or goal conceding. And you can see in the right side, after creating some message options, message passing options, and everything, we formulate the problem as a link prediction problem, and the 4 predictions that you can see in the right side. And is the first intended receiver. Second, what is the outcome of pass actually, if it is going to be successful or turnover. Then what is the expected goal in the next 10 action of the current situation. And what is the opponent expected goal actually in the next 20 action of the current situation. If I want to just, with the tracking data, by the leak that we got, out of all passes in the data set, you can see 74% of the data set of the passes could be marked as a potential penetrative pass situation. It means that we could construct the defensive zone, and there was at least 1 player inside that defensive zone that could receive the ball, actually. So this is a potential situation that we could mark it as penetrative pass. Then we are going to predict who is the intended receiver, and and then we can understand if it was a penetrative attempt or non-penetrative attempt. We can see from here 74% of the data set, the intended receiver was inside the convex hull. It means that it was penetrative attempt, actually. But now we cannot evaluate it because we don't know what is the outcome. This is a pre-events metric somehow. We should know if it was a successful or turnover pass, actually. Therefore, we need to just somehow break it down. Out of all the penetrative attempts, 65% were successful and 35% were turnover. Actually, 65% looks so much because on average of if you check the other statistic, mostly 80% of the passes are successful on average of the other data set. But if when it comes to the penetrative attempts, only 65% are successful. And this shows that this is quite a risky pass. It's not going to be successful as a normal pass, actually, on average. On the other side, if it's going to be successful, you can see the expected goal is 1.8%. It means that if I want to interpret it, it's out of if we consider out of 100 penetrative pass attempts, 1.8 attempts will result in a goal within the next 10 action. On the other side, the expected goal of the opponents, if it's going to be turnover, is minus 0.3%. It means that if they lose the ball actually, and there will be a turnover, then the opponent's team will score a goal in the next 20 actions. Out of 100, 0.3 will be 0.3 goals will be considered. And in the bottom, you can see also the non-penetrative attempt, which 84% are mostly successful, but it's not going to create a lot of value, which is only 0.75% of the expected goal. And 60% will be turnover, and the expected goal of the opponent team will be 0.02%, which is quite low. Now you can see this 35% of the turnover for the penetrative attempts shows a very risky, shows that the penetrative passes are very risky. On the other side, 1.8% of expected goal shows that it's very high, it has a very high reward. It means that it is soon gonna, with a high probability, it's soon gonna result in a goal within the next 10 actions. In order to evaluate that and find some trade-off between this risk and reward, as I said, we cannot easily evaluate that kind of passes because we don't know what is the outcome actually. Therefore, we need to just break it down or decompose this metric into the outcome that are either being successful or unsuccessful. Therefore, we are creating a new metric which is called expected value of penetrative passes, and I'm going to show it with EVPP with the rest of the presentation, which is actually, you can consider it as a variable, and its probability of each outcome multiplied by value of the outcome. Since here we have the successful and turnover outcome, then we are going to multiply the probability of action being the attempts being successful multiplied by xg of that expected goal of that attempt, plus probability of attempt will be turnover multiplied by expected goal of the opponents within the next 20 actions. And if you see on the average of the all data that we had in the data set, the EVPP or expected value of penetrative pass for the actually penetrative attempt was 1.06. It means that out of 100 attempts of the penetrative pass on average, 1.06 goal will be considered, regardless of the outcome of action, if it's going to be successful or turnover. On the other side, for the non-penetrative attempts that you can see in the bottom, the EVPP is 0.62, which is almost half of the penetrative attempts. So these are the total statistics that we got from the data set. If we are going to just show the passing location in the data set that we had, it was actually quite surprising that the penetrative attempt, if you can see the figure in the left side, this is a density function, as you know, kernel-less density estimation. You can see there are mostly like the penetrative attempts are mostly performed in the own half and also in the midfield. There are not many in the attack phase. That was the data that we got it from the league that we analyzed, and it should be similar for the other leagues as well. On the other side, non-penetrative attempts, in the right side, you can see they are more distributed. They could be around the midfield or even in the attacking phase or the own half or any part. Now, if we are going to show what happened for the penetrative passes, where it was successful and where it created the most value, okay, we analyzed that it happened mostly, if we want to analyze the location, it happened mostly in the own half and in the midfield. On the other side, the turnover analysis showed that the more red, darker red that you can see in this figure, it means that there is higher chance of turnover in this situation. It was again surprising that around the midfield, around the half line actually, so in the own half and the midfield, there is a very high chance of turnover. But in the attacking zone, there is not very, it's not very risky. That was quite surprising that we got from the data set. And as much as we analyzed it, the reason was two things, actually. Based off the, first of all, the strategy of the opponents in the attacking field is to just block the shots. Therefore, they are not very concerned about the penetrative passes, and they cannot predict that some penetrative passes will come from the attacking players. They just want to block the shots. this is somehow helps them to distract them from the players who are inside the convex hull, so they can easily pass it to the receiving player in the convex hull, and it can be successful, actually. On the other side, based on the definition, the more farther away penetrative passes tend to be like more risky, because there is more distance between the attempts and the goal line, and so they are like more likely to be turned over by or intercepted by the opponent's player. It's now what to do, okay? We know where is more dangerous and what happened, what was the attempts actually, but now what to do? Where should we try, and where it can create value, actually. That's why we created this EVPP metric that shows us, that somehow creates a balance between the risk and reward. And based on the analysis, you can see this is EVPP's range from 0 to 1. The more darker circles shows 0, and the lighter one shows 1, which is like 100 expected goal. You can see in the attacking zone, actually, in the line that separates the attacking zone with the midfield, the circles are more lighter. It means that we have a better chance of creating value from the attempting penetrative passes from this situation. Therefore, it looks like that the players and team should focus on penetrative passes on this location mostly, because both it can be more successful and it can also create more value. Now we need to create some metric actually for the penetrative passes. The first metric that we introduce is the pass completion. This metric does have nothing to do with the goal actually, nothing about value. It just can compare how teams or players are able to convert or complete the penetrative passes. It means that they have given us potential penetrative pass situation. Now how are they good to complete it, to make a successful penetrative pass? In order to do so, we can, first of all, we are just summing up all the EVPP we got from the attempts that the player had, and it can give us our expectation from that player based on all attempts that they had to convert them into successful penetrative pass, which is showing with expected PP completion, and we are finding a difference between number of actual completion that they have. So the difference between these two numbers gives us some kind of value for that player or team. For example, you can see here team A, the expectation of PP completion was 849. It means that we expect the team A to have, out of all the passes, penetrative situations that they are given to this team, we are expecting team A to have 849 successful passes. On the other side, based on the actual data from their previous data set, they completed 900 passes, and the difference is like 51. So they had 51 more completion, more than our expectation actually, and it shows the overperformance of this team. On the other side, team B, for the team B, this difference is only 21. Therefore, team A is doing better in terms of completion than team B. But so far, yeah, team A is doing better. But so far, this has nothing to do with the expected goal. Now, if you want to, we also analyze it in the player aspect, and if we divide the player into defenders and midfielders and forwarders, you can see more value is created by the forwarders. Remember that this EVPP is the balance or trade-off between risk and reward. Therefore, it looks like that mostly the forwarders should attempt the penetrative passes, regardless of what is the outcome. And the defenders are like more dense with a lower standard variation, and but also lower EVPP. They cannot create more value from doing these attempts. The other thing that we can do is the EVPP performance metric. This is actually what I wanted to show. So the difference between the number of actual goals they scored from the penetrative pass and our expectation from them to convert the potential penetrative pass situation into the goal. This difference also shows how much teams are good at converting potential situation into the goal. You can see in the left side, teams are, in both figures, teams are sorted by the final ranking in the league. There were 21 teams in the data set. You can see in the EVPP performance, it means that the difference between expectation and the number of actual goals they scored, it has a very positive correlation with the final ranking. It means that EVPP actually performed very well, and it could very exactly sort out based on the, you can see there are not any up and down. This exactly it's in the increasing, ascending actually trend. On the other side, if you check the whoscore.com or other website, the distribution between the number of goals and the teams, you can see there are some up and down. For example, I don't know, the fourth and the fourth, from the bottom, the fourth team worked somehow better than the fifth team. They had more goals than the fifth team. So it shows that the number of goals is not a good predictor of the final ranking. And there is not a very nice positive correlation between these two. So yeah, that's it. And we showed, if I just want, is it over time? If I want to just sum it up, we showed the application of event and tracking data to first construct some defensive zones and introduced some method for creating a defensive zones and introduce a potential penetrative path situation. And we provided interpretable analysis between risk and reward. So how can we find a trade-off between risk and reward? And we showed how where actually this kind of potential attempts should be created to be more successful and where we can create more value from these situations. And this kind of, this analysis actually can be used for the teams and coaches for ranking the players according to their penetrative pass performance, both in terms of the completion and in terms of creating value from those. And it can also be used for the player role assignments, which player should be go for forward or which player should be midfielder or defender, fullbacks, and this so on. And we also, this framework can be used for optimizing passing location, which is my favorite topic actually. So we can understand that when we are in a potential penetrative pass situation, where is the optimal direction of the ball, which creates the highest value from those. And it can also be used for tactical planning for the coaches as well. Yeah, thank you for your attention. Just feel free to ask any question or in the break if you have.